So they're going to give you some problems where you're trying to keep something on a hill, to keep something from falling down a hill. And normally what you would do is you have your vector v and your vector u, and you're finding the projection of u onto v. But any problems like these where you want to know what force is required to keep something on a hill, on a slant, something like that, all that you have to do is take this magnitude, this force, times the sine of theta, okay? And this is going to be your theta here. And these problems are all going to be the same, and this is going to save you a ton of time. The book does not teach it this way, but if you actually go through and look at the problems, this is how they end up every single time, okay? So I'm going to do 3 of them like this so you can hopefully see the pattern. So the first one is example 6, which is on page 504. A 3,000-pound car sits on a hill inclined at 30 degrees. And they have a picture. So you have a 3,000-pound car. And that's, for this particular one, we have the 3,000 pounds, that's our force, inclined on a 30-degree hill. Ignoring the force of friction, what force is required to keep the car from rolling down the hill? So this is what you're trying to find right here. So we take 3,000 times the sine of 30. So sine of 30 is 1/2. Half of 3,000 is 1,500 pounds. That's the force that will be needed to keep the car in place. Okay? So, guided practice 6. Mary sits on a sled on the side of a hill inclined at 60 degrees. So we have Mary, okay? Incline is 60 degrees. What force is required to keep the sled from sliding down the hill if Mary and the sled weigh 125 pounds? So Mary and the sled weigh 125 pounds. So again, you take that force, 125, times the sine of your angle of inclination, the angle of inclination, and then angle of incline. And this one, sine of 60, is square root of 3/2. Not a nice number. And so I'm going to take the calculator and do 125 times the sine of 60. And so it's 108.3 pounds. One more. A 10,000-pound boulder sits on a mountain at an incline of 60 degrees. So very similar picture as the last one. So you have a boulder and it's 10,000 pounds. Incline 60 degrees. Ignoring the force of friction, what force is required to keep the boulder from rolling down the hill? So again, we're looking for the force that would require it to keep from rolling down the hill. So I just do 10,000 times the sine of 60. Again, sine of 60 is square root of 3/2. They're looking for a number. So it's going to be 8,660.3 pounds.